So we're in our books now, and this is the last section that we're going to cover this unit. So your quiz is over 4.1 to 4.4 on Monday, and that's what you'll be tested over also, okay, is these 4 sections. So this will be the last section that we cover, all right, in this unit, graphing linear equations and slope-intercept. Well, yesterday you were quizzed over graphing linear equations, right? What did you use to graph it? You guys remember? No, to graph. Yeah, no. To graph a linear equation, you use your tables, right? And your x values, -2, 0, and 2. We use tables to graph linear equations. There are other ways that we can graph the exact same equation. And one of those ways is to use slope-intercept form. All right, the first thing you need to know is what is slope-intercept form. This is really important. The y equals mx plus b. Y equals mx plus b. And it's important that we understand what each part of this equation stands for. So that's why I kind of broke it down and tried to color code it. That x and y stand for the ordered pair still. That m is our slope or our rate of change between 2 points. And b is the y-intercept, where the line crosses the y-axis. So that's going to be really important when I'm graphing using slope-intercept form. All right, so go ahead and write this down. Got it written down? You guys got it? All right, so this really is kind of like our starting point or our basis whenever we're looking at equations and trying to graph using our slope and y-intercept. All right, and that's what we see here in example 1, okay? In example 1, the reason I wrote your formula here is because this is our starting point, or basically what tells us which values stand for which variables in the equation. All right, and that's really important when we're trying to graph it. All right, so what they want us to do, and you're going to have a section like this on your homework, on your quiz, and on your test next week. They want us to identify what is the slope and what is the y-intercept. And I know that those are kind of weird variables. Do you agree that m is kind of like an odd variable to use for slope, right? It doesn't really have any letters that are in the word slope, but m is slope. M is the variable that stands for slope. So I look at the equation, and what number has been substituted into the equation for m? What number? -4. So I'm just pulling it out. M equals -4. Okay, M equals -4. And what number has been substituted into the equation for B? -2. Okay, so that's all we need to recognize in order to graph the equation. No table, no ordered pairs, that's all we need. So go ahead and set up a graph, and we're going to go ahead and graph this equation. All you need to know is what is M and what is B. All right, so go ahead and set up your graph on your papers. You can use graph paper, or you can do it right there in your notes. Just make sure you are using a straight edge. And guys, don't squish your numbers together. Use the lines to kind of draw your grid lines. All right, let's go ahead and set up our graph. Here's what my rule says. If I'm graphing an equation using slope and y-intercept, whatever number is my B value will be the first point on my graph, because this value tells me where the line is crossing the y-axis. So because B stands for my y-intercept, I'm going to plot a point at -2. At -2. I know I just covered up my number, but that point is at -2. So whatever your B value is, guys, if it was 4, I'd plot the point on a +4. Remember, this is y. This is my y-axis. All right? So again, I really didn't even do any work. I just know now how to read the equation, and the last number in the equation, this -2, that tells me where it crosses the y-axis. And now I'm going to use my slope to figure out where my next point is. But with slope, it needs to be rise over run, and I only have one number. What can I put a whole number over? Can I put a whole number over? 1. So this could be -4 over 1. And now I have my rise over my run. Remember, guys, if there's a negative, that means that my rise is negative. It's never my run that's negative, okay? So from my first point that I just plotted, now I'm going to go down 4 and over 1 and plot my point. Down 4 over 1, plot my point, and I draw my line through the points with an arrow on each end of the line. And the arrow on each end of the line says that my solutions are still infinite, just like we talked about in 4.1. These are not the only two solutions to the linear equation, okay? It's just two. It is two of them, but it's not the only two. So now let's do another one. Now on this next one, I want you to use the same graph that you just used, okay? So we're going to do 2 lines on that same graph so we don't have to keep drawing our graphs. Now we're going to look at this equation. It's probably a good idea if you have a different color pen or pencil, or maybe even a highlighter, to just kind of differentiate between your 2 lines. Y equals 3x minus 7. Here's the first thing I want you to do. What is your slope? And what is your y-intercept? Again, we have to pull out these values so we know where to plot the points on our graph. Okay, so again, my starting point is my formula. Y equals mx plus b. So which number did I plug in for m? Which number plugged in for m? Mason, which number did you plug in for m? Here in this equation, which number is substituted in for m? 3. So my slope is 3, or I could write it 3 over what? 3 over 1, and that's going to help me graph it. Okay, 3 over 1. What's my b value? What's my b value, Joshua? -7. All right, so based on what we just talked about in the last example, I want you to try to plot the first point on your graph. You don't need a table. You don't need ordered pairs. You already know where your first point needs to go. Go ahead and plot that on your graph. Where is your first point going to go? Lily? Very good. It's going to go -7. Whatever my b value is, that's where my first point is going to go. -7. Where do I go from there? Sarah? Very good. Now, we need to make sure, guys, are you paying attention? Okay? We need to make sure that we're following the steps. So, rise over run. I need to rise 3, and I always run forward however many units. In this case, it's going to be 1. Okay, rise over run. All right. But my graph isn't finished. What do I still need? Just tell me. I need my arrows, because my arrows tell me that my solutions actually keep going to infinity. All right, so now we've got 2 graphs under our belt. Okay? All right, so now let's look at these 2 equations. Okay? Again, and guys, I'm telling you, you're going to hear this many more times before we get to the end of the lesson. Y equals mx plus b. This has got to be my starting point, okay? So my equation, before I can identify what my slope and y-intercept is, it has to be in this format, all right? So look at this first equation. Write it down. Y minus 5 equals 3 over 2x. Y minus 5 equals 3 over 2x. Go ahead and write that down. Okay, is it in slope-intercept form, guys? Is y by itself? So here's how I know. Y has to be by itself on the left side, and y over here is not by itself. It's connected to -5. So how can I get -5 to cancel to the other side? Joshua? Yeah, very good. I need to add 5 to both sides. Guys, this is actually what we did all the way back in chapter 1. And this is why I keep putting it on your test to remind you, like, this is not going away. Solving for y is so important for algebra, that we can do this, and that it becomes a little more automatic for us, okay? That we can do this kind of effortlessly, Okay, so now we have the y equals. But what term comes first on the right side? Would it be my term with the x or the number by itself? The term with the x. According to my formula, the term with the x comes next. So it's 3 over 2x plus 5. And now it's in slope-intercept form. And now I can say m equals what? What does m equal? 3 over 2. Caitlin, what does b equal? B equals what?
5.
Very good. B equals 5. All right, I want you to do the same thing on the second equation now. All right, go ahead and, again, it's not in slope-intercept form, so I can't identify my m and my b yet. Okay, so now we are going to talk about the graph, though. So what do I do first on both sides? Mason? Add 1 to both sides. Okay, and again, not like terms, I cannot add these together. All right, so y equals, which term do I write first? Negative 2/3 x or 1? Yes, because my x term has to come first, plus 1. So now let's see, Anthony, what's my m value? M equals what?
Negative 2/3.
Very good, negative 2/3. And Ethan, what's going to be my b? 1. So if I were to graph this, where would my first point go if I were to graph it? At a y value of 1. And then where would I go from there? Down 2 over 3, plot my point, and I'm done graphing. All right, so now we're going to set up one more graph. Okay, so 2 more equations, 1 more graph. The first thing I need to make sure of is my equation in slope-intercept form? If it is, I can do m equals and b equals, and then I'm ready to graph. All right, so write the equation, find your m, find your b, and graph it. All right, so now this is the third one we're doing, so hopefully we know more of kind of what we're doing, and we can do more on our own. So everyone, what is your m? What's your m? Now, is it okay if I put it over 1? Okay, and why would I do that? To remind you that you need to run 1. Okay, otherwise you might try to do 0, and that would be a vertical line, and bad. Okay, so what is your b? 3. Okay, so now I'm ready to graph. Where does my first point go? At a y value of 3. So a lot of people are mixing that up and trying to plot it down here on an x value of 3. Remember, it's not the x-intercept. That's the y-intercept. All right, and whatever number your b value is, that's where the point goes. Now, from this point, where do I go?
Down 3 and then
How did you know you were going down 3? Because it's negative. But when it's negative, does that mean I go left on the run? No, I never go left. I always go right. So I go down 3 over 1, plot my point, and I can draw my line, and I've graphed the linear equation. All right, now this might seem repetitive, but we're going to do one more on this same graph, okay, on your papers. Now this last one, I'm kind of testing you on a couple concepts that I've taught you, okay? You guys ready? Okay, we're going to graph this linear equation. All right, so you need your m equals and you need your b equals. Go ahead and write this equation down in your notes. Y minus 2 equals negative 2/3 x. Y minus 2 equals negative 2/3 x. Go ahead and write that down. Is it ready to graph?
No.
The answer is no. Why, Maya? Very good. It's not in slope-intercept form. All right, and she just even said what needs to happen. All right, so we just solved a couple of these that were not in slope-intercept form. Y needs to be by itself, so what would I do to both sides? Just tell me. I need to add 2 to both sides. So before I can say this is my slope and this is my y-intercept, it needs to be in slope-intercept form first. And remember, x comes first and then my b. Okay, so now that I've done that, I can say m equals and b equals. Again, we need to get used to these variables. M stands for slope, b stands for the y-intercept. Go ahead and write down now on your notes m equals and b equals, and then go ahead and graph this line on the graph that we just did in the last example. So we're going to have 2 lines on that graph. So everyone, what does m equal? Negative 2/3, and b equals 2. So where does our first point go?
2.
On a 2, and where do I go from there?
Down 2 over 3.
Down 2 over 3. Draw my line and my arrows, and I'm done. All right, now on your homework you have 1 graph, so make sure you do it on graph paper. I just need to make sure that everything is kind of like proportionate, that you're going unit by unit, so that's why I'd like to have it on graph paper. All right, last concept we need to talk about today is identifying whether or not 2 lines now are parallel. Okay, and this directly ties into slope-intercept form and slope, because my equations must be in slope-intercept form in order for me to identify whether or not my slopes are the same. Here's what I need you to write down in your notes. Parallel lines, or 2 lines are parallel. Okay, actually, write it this way. Parallel lines have the same slope. Parallel lines have the same slope. All right, I guess I'll write that down too. Parallel lines have the same slope. Because think about it, they can never intersect. All right, so in order for parallel lines to never intersect, they have to be slanted exactly the same way. And from point to point, my rise over run has to be the exact same. So otherwise, they're going to intersect at some point. So parallel lines have the same slope. So that's what I'm looking at between 2 equations. First of all, I need to make sure that they're both in slope-intercept form. All right, so as you're writing down these first 2 equations, I want you to tell me whether or not, yes or no, they're in slope-intercept. And then here's the only criteria for parallel lines. Do they have the same slope? That tells me yes or no. Okay, so as you're writing it down, do these equations have the same slope?
Yes.
So as long as you know where to look, it's the number connected to the x. As long as those numbers are the same, then yes, these lines are parallel. It doesn't matter that the b's are different. That just tells me that they intersect the y-axis on different values. That doesn't matter. The only thing that matters is the slope. Okay? So I would say yes, same slope. That's my reasoning. Yes, it's the same slope. Okay? So go ahead and write down the next set of equations. Okay? Write down the next set of equations and then answer yes or no. And guys, it's as simple as, does it have the same slope or not? Okay, so write them down and answer the question. Okay, so on the first one, on the second set of equations, is it yes or no?
No.
No, because it's different slopes. Slopes are -2 and +2. Okay, so it's no. All right, and truthfully, you saying what the slopes are, that really tells me even more that you weren't just guessing. Okay, so on the quiz and on your homework, they may ask for that y part of it. Just tell me what the slope is. If the slopes are the same, great. If they're different, tell me what they were. Okay, so now let's look at this set of equations. Okay, 2 equations. 2 equations. We need to tell, are these 2 lines parallel? Are these 2 lines parallel? 3y equals -6x plus 9, and y equals -3x plus 3. These 2 equations, are they parallel? All right, so go ahead and write those 2 down. We're almost done. Just got a couple minutes left. Are these 2 equations both in slope-intercept form currently?
No.
They are not. So while my slopes look like they're probably different here, that tells me nothing because they're not both in slope-intercept form yet. Okay, and this is going to be on your quiz where you have to kind of uncover it. How do you do that? You have to write both equations in slope-intercept form. This is something that we've been doing since chapter 1, We're just kind of looking at it now, calling it what it is in that slope-intercept form. So what would I need to do? This equation on the right is already slope-intercept. Y is by itself, then x, then b. But what do I need to do to this first equation? Don't say it out loud yet. Go ahead and write it on your papers to give everybody a chance. What would I need to do to this first equation? Again, this is something that we've learned, okay, across the entire equation. Did you write it down? Okay. To solve for y. Sarah, what are we going to do? Very good. Divide everything by 3. And that's how I get y by itself. Now y equals what? Negative 2x plus 3. Okay? So are these the same slope? They are not the same slope. One is negative 2x and one is negative 3x. So my answer is no, because the slopes are negative 2 and negative 3. Okay? So that's the answer. Now, if you didn't show your work and you just were to say no, you get the answer wrong because you didn't catch that they both weren't already in slope-intercept. So you have to write them in slope-intercept before you can answer it. All right, any questions? Okay, that's everything you need to know for section 4.4.